Oh, you know what? I forgot to say something, guys. That was part A.
What?
I didn't mention what part B was. How terrible. Well, first off, does everyone have, you're still writing? You're good? Part B. Solve the system using the inverse of a matrix. Your third and final way of solving a system, we already did elimination, we just did Gauss-Jordan, and now the third one is using the inverse of a matrix. So what's going to happen is you're going to use your inverse from the first part. Let me see if I can copy this. Copy! And then can I go to the next slide? You have to announce it like that, otherwise it doesn't. Okay. Can I go here and say paste? Paste! Oh my gosh. It's amazing. So we just found the inverse. I don't know how to get rid of that, so ignore that thing right there. What does this button do? Oh my gosh, stop, I love you. Delete. No! 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 Hi, class. We just found the inverse of the coefficients in the previous problem. If you look at those coefficients, 1, 2, negative 2, 4, 7, 1, 3, 6, negative 5. We already found that inverse. If you forgot, there they are right there. So what you do is to find the inverse, to solve the system using an inverse, you take your inverse and you multiply it by the constants. In this case, 1, 19, 5. So to solve a system using an inverse of a matrix, you take the inverse that we just found in part A, and you multiply it by the constants. You might say, why? Well, I'll tell you why. Let's step back a little bit. What if I gave you the problem 2x equals 3? If you're only allowed to use multiplication, what would you multiply both sides by to get x all by itself? Half, because a half and 2 are inverses of one another. So you've been doing this for a while now. Correct. So these two would cancel because their coefficient would now make a 1. So in other words, we just write an x. And notice what you're doing is you're using the inverse of 2 times the constant 3. And that's what would give you the answer in this case of 3/2. Same concept here. You multiply the inverse by the constant. So that's why we needed the previous section, i.e. how to multiply matrices, because this is where you use it. Now, I know these are big numbers, 41, negative 23. So, yeah, you might have to bust it out. But we have a 3 by 3 and a, how many rows does this have? How many columns does it have? 1. So the number of columns here matches the number of rows here. Ugh. So the end result will be a 3 by 1. However, the 3 by 1 answer will have meaning. The first number is what x equals, and then y, and then z. Because that's the order of the variables in the original problem. So you'll take this row and multiply it by this column, just like we did a couple times already today. So you'll say 41 times 1 plus 2 times 19. So I don't know what this answer is, even though I do, because I have the answer right here. I got -1. Thanks. So what's the next one? Yep. So -23 times 1 plus -1 times 19 plus 9 times 5. I got 3. And then one more. So -3 times 1 plus 0 times 19, that's nice. Plus 1 times 5 is 2. So as an order triple, we get -1, 3, 2.